So hello everyone, greeting of the day to all of you, and welcome back to the day 2 of Chaos Carnival. I'm Abhishek and I'll be your host for today. I hope, so we had an amazing keynote, great and interesting sessions, bootcamp and fun activities including quizzes, etc. And I really enjoyed the day 1 of Chaos Carnival. I hope you did too. I'm really excited to welcome you all for the day 2. So before we move ahead for the keynote, and let me quickly tell you about agenda for today. So we're gonna kick off with our keynote first, followed by 15 parallel sessions and a boot camp. We also have some fun activities in between the sessions, and of course some exciting gifts for the quiz winners. And I'm sure you will enjoy it and you'll like it too. Post session we'll have our closing note, and the winner for the quizzes and activities will be announced during the closing session itself. And moving forward, I have few more points related to logistics and COC part. So let me quickly tell you about them. About that. Sorry. So if you're watching this on YouTube, you want to join the session using the link in the description. We have interacting sessions, sponsor booths, bootcamp setup on this platform. And if you are on AirMeet, you have a chat box on the right side of your screen. You can post things in the lobby, and you can also post questions related to your session on the Q&A tab. And we have individual hosts for each session. They will take care of, and also they'll help you in reading your questions and if you have any other doubts. And if you want to interact with speakers also, if time permits, you can raise your hand and respective host will let you in on the stage as well. And to give a real essence to the conference, we also have a social launch on the platform, which is a networking lobby with all sort of table arrangements where you can actually do a networking session just like a real networking session in the conference and meet the fellow attendees. And last but not the least, we request you to follow our code of conduct and be respectful and behave nicely with fellow attendees. The code of conduct can be found on our website, chaoscarnival.io/coc. And if you find someone behaving inappropriately, either during the session or normal networking session or a chat, you can use the menu option to report them, or you can reach out to organizers. So without any further delay, let me introduce our keynote speaker of the day. He is the CEO of Chaos Native and maintainer of LitmusChaos project. He is an entrepreneur and technology visionary who earlier co-founded CloudByte and Metadata. His team built LitmusChaos in last 3 years to make chaos engineering easier to the modern DevOps ecosystem. His focus now is on building chaos solution at scale for enterprise and making chaos a first-hand tool for cloud-native developers. He has master's degree from Illinois Institute of Technology, Chicago as well. So please welcome Uma Mukkara.
Thank you, Abhishek. Nice to be here. Hello, everyone. Welcome to Chaos Carnival. The second day keynote I'm going to kickstart. Let me share my screen. You can see my screen, right, Abhishek? Abhishek, are you good?
Yes, Uma, we can see your screen.
All right. Good morning, good afternoon, good evening. For some ones late in the evening, good night as well. Hello, everyone. Let's start this Chaos Carnival keynote with the day 2. And I'm going to really talk a little bit in depth about resilience for cloud native ecosystem or cloud native applications. Before we delve into that, a little bit about me and the company that I'm with. I'm Uma Mukkara. I'm the CEO of Chaos Native. We actually spun off from my data yesterday. Some of you might have seen the news. And I'm also a maintainer of LitmusChaos, which is a Cncf sandbox project. I live in Bangalore, India with my 2 boys and my wife. Basically, I'm a technology architect, technologist. About 10 years ago, I ventured into entrepreneurship, founding CloudByte, which is a storage company for service providers. Then I happened to pivot that company into cloud native ecosystem, starting OpenEBS, and later we named the company as Maya Data. So while I was doing OpenEBS, got really interested as an opportunity into cloud native chaos to start Litmus, which became basically a big success in terms of open source adoption, traction. So then we helped found this conference, Chaos Carnival, in order to build a larger momentum or platform to share all our thoughts together. And finally, we want to take this to enterprises to adopt Litmus for enterprises. So really starting Chaos Native, right? So what we're going to talk today is about reliability for cloud native system. Reliability or resilience is resilience for operations using chaos engineering. That's how we all understood it as, right? And cloud native, how we understand that as basically it starts with containerization, break things into microservices, and a lot of CI/CD will come into the play. And you try to scale this microservices using GitOps. Finally, it has to result in faster application delivery, right? So that's my way of summarizing what's cloud native is. There's a detailed definition, of course, that is provided by Cncf. I'm just tuning it a little bit for my talk here. So what about cloud native reliability then, right? So it's really about reliability, getting resilience for operations and so forth in a cloud native ecosystem, right? So, and eventually you have to get faster application delivery and still keep the resilience intact, right? So that's what resilience for cloud native applications is. Just because you're getting a lot of advantages of containerization and so forth with cloud native ecosystem, we don't want to reduce our expectations on resilience. So there are some opportunities and challenges which we saw through, and finally we are here, right? Before we go into cloud native chaos engineering, I just really want to touch upon traditional chaos engineering. A lot of great speakers yesterday spoke about chaos engineering in general, so I'll not take too much time. I'll probably say that chaos engineering is really about avoiding expensive downtimes, right? So downtimes are expensive. That's how people will say, why do you need chaos engineering? And I don't want to get into a big downtime with a lot of financial loss. So what people really do is they suggest you keep testing in production on the operations side also, right? Don't just observe and wait, but test and find out and do some chaos testing. That's how the chaos engineering is generally observed as. And today, the general understanding of chaos engineering is the following, right? It's not a new concept. It all exists. Last 10 years, there are a lot of theory and good practices about chaos engineering. And it is still limited to experts and enthusiasts. It's not like a common practice everywhere, right? And it is still limited to large deployments. You don't see chaos engineering being practiced in smaller ecosystems. Generally speaking, chaos engineering, one would start, unless you're an expert or enthusiast, I would say that you have burnt your fingers somewhere and then realize that you should have tested that, or chaos engineering is the way to go, right? So it's mostly reactive stuff. You are not seeing doing chaos engineering as a proactive breaking things on purpose very often, right? So that's been the state till recently, but that's all changed now, right? And how we've been doing this typically is using game days, and rarely you integrate into CI/CD. And typically it is the SREs, not the developers or the admins, CI pipeline admins that do chaos engineering. And you measure it with your own scripts and tools. And observability is also, there have not been great tools that are specifically targeted towards depicting chaos, and execution and planning has been no tooling around that as well, right? So chaos engineering, in summary, is not a new field. It's a well understood one, but it's not yet ready. It has not been yet ready for the modern day DevOps, right? So it's that's basically the summary of it. Before I talk about chaos in cloud native, let's see actually where is cloud native and chaos themselves are in this environment in terms of the state. All right. So if you see cloud native itself, we all very well know that Kubernetes is very well adopted. And the fact that we are having this, we're talking here itself means that Kubernetes has a great role to play in it. And Kubernetes is understood to have crossed the chasm, and we are on the right side, mainstream market. What about chaos engineering? Right, chaos engineering. I believe that it is on the left side. It's an early market. There has been a lot of innovations in the last 18 months. I would say a lot of traction. A lot of people are coming forward. You see many conferences are happening. A lot of surveys are happening. Cncf has declared it as the top trending technology for this year. I see this moving towards chasm or crossing it in the next couple of years, or next year. So let's talk about chaos engineering in cloud native, right? So it's really, if you are trying to do chaos engineering in cloud native, I'm trying to call it as cloud native chaos engineering, or CNCE. Generally, I've written a couple of blogs on that. So why should there be any difference in doing chaos engineering for cloud native? Why can't I do the regular chaos engineering principles or tools or the way of doing it? So fundamentally, cloud native itself is different. That's why there's a big follow on here in the industry. My take is it has to be different because things are more dynamic. Also, DevOps has changed completely with respect to where things can break. Right? Let me unpack this a little. More dynamism is primarily because of the containerization. An application is being broken up into multiple microservices. You're not dealing with 5 applications now. You're probably dealing with 100 microservices or more, right? And that's too much of scripting. And also the CI/CD, which has been there for quite some time, you see a lot of advancements there as well, right? So CI/CD pipelines are more ubiquitous now, and which really meaning that you're not releasing 90 days releases anymore. Even though there are multiple microservices, you're able to get them fast because you are having a good CI/CD system, right? So more applications or more microservices are coming almost every week if you're running a large system, right? So that's what cloud native dynamism is. You don't have a choice, and you had to make sure that resilience is intact, right? So why I can actually see it's primarily driven by CNCF. There's a lot of innovation, coordination, collaboration that's happening in this ecosystem, right? All are working actually pretty well together. So what is the net effect? Net effect is you're getting the changes into your environment much faster than you were prepared for, right? And there's a lot of work going on in CNCF. You can see CNCF SIGAP delivery. There is a separate SIG which deals with various challenges around how can I deliver things fast, safe, secure, all that stuff, right? That's one part. DevOps, we all know it has changed recently, but it's not just about shipping left, but it's about infrastructure provisioning, right? So infrastructure is now declarative, and developers, they don't ask for someone else to provision the infrastructure. They go ahead and take control and then provision, then move on, right? So because you have a declarative API and everything works very well, right? And at scale also it's happening with the GitOps rise as a practice. So finally, what is happening on the DevOps side is you're creating infrastructure because it's easy and possible, and you're getting it fast and you're getting it right? But faults generally happen in infrastructure, right? And you're provisioning them so fast, so there is more chance of things breaking, right? So resilience definitely is in a question, right? So that's why chaos engineering has to be different in cloud native, right? More dynamism and DevOps has changed, right? So we'll talk about what is that chaos engineering for cloud native is, or what is cloud native chaos engineering. So I have come up with 5 principles of cloud native chaos engineering. These are not something rocket science, but more of an observation and putting together and observing why cloud native or Kubernetes ecosystem is so successful, right? So first of all, it's about open source, right? You're talking about chaos engineering. Are you choosing a platform that is open source, right? And Kubernetes is a good example. So you want things to be in open source so that it's well cooked, collaborated, all that stuff. And chaos experiments should be community collaborated. There is a lot that you need to do with so much of dynamism. You don't want to be writing the basic things, right? So you want to pick a well-defined, well-tested experiments for 50% of your chaos needs. And then get a head start and then move on with your real chaos needs of your legacy applications or your own private applications, right? So that's where we talk about community collaboration. I'll talk about Chaos Hub as a result of this principle, right? And then we all know in cloud native systems, things have to be versioned, right? So there is a lifecycle problem, there are operators and all, or the solutions for that problem. So you need to follow chaos management. Also had to follow those principles, like having an operator, having a CRD, being able to upgrade your experiments from one version to other version, coexist, backward compatibility, all that stuff, right? So you need to be able to scale them using GitOps at a higher level. So GitOps itself is the key in cloud native ecosystem, right? So things have to be declarative, and if you're doing breaking things on purpose, chaos engineering on that large dynamically provisioned infrastructure, dynamically updated applications, you need to have GitOps built into chaos engineering itself, right? So finally, this is something that I added recently: observability. Observability is a big deal, right? As usual, things are breaking, and that's why you are trying to tune the system with chaos engineering, so you're actually going to break more. So what happened at that time, because of what, is a big deal, right? So you need to have some common way of observing things when chaos is in play, right? So in summary, cloud native chaos engineering has to have these 5 principles, and I would like to introduce at this point, we have come a long way in actually developing Litmus according to these principles. There's some marked here in red, or this theme color, slight pinkish color, which means that they're already done. The ones in white are about to be done, right? So Litmus is the Cncf open source project that actually tries to adhere, or we developed to adhere to these principles, right? So Litmus 1.x is been in usage for last 1 year or so, and then we are reaching 1.14 or 1.13. We are getting Litmus 2.0 out with GitOps and observability, right? So let's talk a little bit about Litmus. It's a complete tool set. It's a CNCF sandbox project. We have applied for incubation in the next couple of months. So you should see the due diligence and all going through, hopefully. And it is a proper platform and tool set to do cloud native chaos engineering. All right. So what are the components that you get with Litmus, right? It's basically a simple Helm chart, and you already have a chaos hub, and then you will end up having your own experiments called private chaos hub, right? So you use that Helm chart to do Litmus Portal. For those of you who are listening to this on current Litmus, This is, I'm talking a little bit advanced, 2.0, right? So where we have introduced Portal a few months back. So it's a little bit current architecture. You might need to look at the docs. But basically, Litmus is installed using Helm chart, and then experiments are pulled in from public, and then you can create new experiments, keep them in private hub, and collaborate. And then you can run chaos workflows on any cloud or any on-prem Kubernetes systems, right? From this one single Litmus portal. It's not limited to running only on Kubernetes. You can run them on VMs, and bare metals. You can run them very well. And you can also keep all this very well tied into GitOps with Argo CD or Flux CD or Spinnaker, or and so forth, right? So that's how Litmus looks like. Let's actually get a little bit more in detail. So Litmus portal, you run a chaos workflow on a target, right? Either on the same target as that Kubernetes, or you can run it on a namespace or any other cluster outside that Kubernetes, right? So once that chaos workflow is issued onto the agent on the other side, the operator comes up, it gets installed, comes up and runs the experiments, and you can keep running. So multiple targets can still be managed from a single portal with RBACs in its place. And finally, chaos results are pushed back to the portal, and metrics are pushed back into a Prometheus or other monitoring databases. Right. So basically, you have chaos interleaved analytics as a result. You can have the entire chaos management across your multi-cloud system, Kubernetes, non-Kubernetes, everything from one single Litmus portal. And this is all 100% open source, and it's highly scalable. So how we achieve that scalability, one of the things is the chaos workflow itself, and we chose to use Argo workflow, which is a Cncf incubating project, as the fundamental component of it, right? So LitmusChaos workflow has Argo workflow as the kind, and instead of Argo workflow stages, it will have each stage as an experiment. So you can actually sequence the experiment, make them run them in parallel, and in addition, you consolidate the results and then push it back as a chaos result into portal and metrics, right? So this is really what fundamentally enables GitOps for chaos engineering. So it's not only the chaos experiments that are declarative in nature. You're able to create chaos scenarios, chaos templates, chaos test cases in a way that you want very easily, and manage them at scale and monitor them the way you need it, right? And reliably. So that's really Litmus 2.0 is all about. So let's see how this all works, right? So you have a chaos hub, and you pull in Litmus portal, and you pull in a target, and you run a chaos workflow, right? So the chaos workflow will pull the experiments referring to the private or public chaos hubs, and those experiments are there. And then it'll have a chaos engine that will instantiate chaos operator kickstarting. Basically, chaos operator will be watching, and you will have all this CRDs coming into play, and the experiments get will be the key end result, right? So this is for one workflow, right? So Litmus is about first we did operate the Litmus portal. So it's all coming together, observability, GitOps, right? So you can see how it all evolved, right? And experiments list, it's growing. We have 40 plus experiments, and with all this new focus, I'm pretty sure we'll have another 40 this year added in 2021. But we have right now, I can say that most of the stuff that you need in cloud native chaos, you can do it with your existing, and some of them are in roadmap, of course, always, right? So you have pod, node, and network, and stress chaos, cloud services. We have great contributions from Intuit on AWS side, and some application developers are coming and putting in their chaos onto Chaos Hub, right? So observability advancement is another thing. You will see probes are a way to define your steady state hypothesis, right? We give experiments, but we don't define your steady state. You can declare it yourself. And using probes, you can do a detailed hypothesis construction. And once the results are put in using annotations, you can actually go and paint the chaos duration on your Grafana dashboards, right? So you will know a problem in your system is because you introduced chaos or it naturally happened, and you can correlate and compare and deduce some tunable parameter to be put in place. So Litmus also gives a lot of chaos analytics related to workflow and experiments. So together with this dashboards application, chaos interleaves dashboards, as well as your chaos workflow analytics, you can put them together and really find out what's happening at scale, compare in the past, and compare across the workflows, systems, and then make some good decisions. So other things that we keep getting is how about CI/CD? That's also where I need. So we have developed a LitmusChaos CI wrapper, a library which can run these workflows underneath. And this wrapper or CI library is used by the CI tools. For example, you introduce a chaos stage into your pipeline, and GitLab, you can use GitLab remote template, can use this library and then call that chaos workflow. And we have integrated with the GitHub Actions recently with Spinnaker, and we also did with Captain. So these are the current CI tools that we have introduced, integrated. A lot more is coming, right? So other thing is Litmus is a Kubernetes application, but it's not just for Kubernetes targets, right? So for example, we have EC2 terminate and EBS detach on Amazon Web Services, and the GPT detach in Google Cloud, and more can be done, right? So they're all coming in the roadmap. So how it works really is, it is still a chaos workflow that gets executed on the Kubernetes environment, but through the network access APIs of either this cloud providers or through this OpenStack, wherever is the target, you can customize that experiment on how to introduce that chaos or kill, right? So basically that's how it is. And you can have a multi-cloud environment having a chaos management is going to be pretty easy because the layer will work with both of them, right? So what are we doing with Cncf projects, right? So today we already have great integrations with Argo Workflow, Argo CD, Captain, OpenABS, of course, and then Container D and Cryo runtimes. And we are having plans to have better integrations with the Flux, GitOps, Purpose, Crossplane. That's a declarative, multi-cloud declarative control plane. And database, a popular one, and open policy agent for security control, right? So these are the short-term, medium-term roadmaps, but more may happen now that we have more focus. I'll not go much into the details, but the slides will be available on the Slack channel of Chaos Carnival Slack community. Go ahead and take a look at it. So now I want to spend some time on Chaos Native for Litmus. We announced this company yesterday. Why did we announce this, right? So the primary journey where we got here is we started with solving reliability issues for OpenEBS, and we wrote our chaos on test because nothing was available at that time that for our liking. And then we started Litmus as an internal project, and then we open sourced it. We donated it to Cncf, And then there's a large uptake of this project by users and contributors. We have many contributors right now from different companies. And now people are asking for support as well. There have been many queries and a lot of interest. So we are launching Chaos Native primarily to provide support for enterprise users. And the goal here is really to accelerate the enterprise adoption of Litmus, right? So how can we, the architecture we believe is right, but enterprise uptake or adoption really requires somebody standing behind it. And we spun off from my data to stand as Chaos Native, which is like solely focused on Litmus and success of Litmus usage by enterprises, right? So how are we going to do it? We are really going to do it by building a stronger Litmus community, right? So community is paramount, and only when you have multiple vendors coming together as maintainers, a lot of contributions coming from the community, helping each other, then the project will be much stronger, right? So apart from that, we are going to provide enterprise support and a lot of tools integration like Spinnaker and other things. We'll put resources into it. We'll try to test with various distributions of Kubernetes, and air-gapped chaos engineering is still something flaky. We're going to close that gap there. And a lot of large customers require managed services. They need Chaos as a managed service as well. And then we are going to try to bring Chaos for developers, right? Just like you have a CI file working along with your code, you might have a Chaos file to test your code as well, right? And things like that is what our vision is, right? Finally, I would like to say, what is this? This is all great, but I've been already using Litmus. Should I be worried? Right? No, you should not be. You should be actually, you have more options now, right? You can continue and you should continue using Litmus, and we will continue to be more as active, if not more active, on the Slack support channels, and we'll also help enterprise support and managed services and so forth, right? Everything will be open source. Chaos Native does not develop any code in closed source, right? So that open source philosophy will continue, all that stuff. So finally, I just want to do some predictions for Cloud Native Chaos before ending this keynote for Q&A. These are my own predictions, disclaimer, right? So some of it is based on some data or primarily my observations and putting things together kind of a thing, right? So we've been talking a lot about chaos experiments, but basically they will become a commodity, right? So you will get experiments at will, and it's all about chaos workflows, writing probes and writing hypotheses, right? You don't need to develop a lot of experiments. You just need to put them together, right? So that's what will happen. And chaos, again, will be part of a larger ecosystem. It will be completely automated. I don't know how long it will take. I cannot predict that, probably 2 to 3 years. But definitely there is uptake already, and it will be taken. GitOps is definitely on the rise, right? And then you will see some offerings coming to offer chaos, both for SREs as well as for developers. For one, Cloud Native definitely, Chaos Native has definitely plans to launch Chaos as a service. And developers will end up having chaos testing as a first-hand tool, apart from their unit testing and other things, right? So that's my prediction. So with that, I really want to thank you for your audience, and we can take it up for questions.
Sure. Thank you so much, Uma.
We have about 10 minutes.
Yeah, we have 10 more minutes, so no worries. Let me get a question. So the question is from Mohan. He's asking how easy or hard it is to develop this integration for other CI pipelines. That's a good question.
Yes. So we have a good API for Chaos experiments and workflows, and we built an API wrapper for CI integration as well. The wrapper is already there. For example, with Spinnaker, we did it in a week, right? You just need to understand the API side of that side, the tooling side, and here. And the initial integration can be done in a week. It can be done. A lot of community members are coming forward. We're hoping that in the next year we'll have integration for all the CI tools.
I also have few questions. Like I'll take one from my bucket also as well. So does this Litmus support chaos on non-Kubernetes infrastructure? Like, can we use on-prem VMs or cloud platform services or availability zones?
Yes, definitely. I think, as I said, we already have a couple of experiments, or more than couple, to introduce chaos onto EC2, AWS EC2, and also AWS storage, EBS, Google storage. So we have the infrastructure ready for that to introduce non-Kubernetes target chaos. You just, if you want it right now, you can use our API and also the target API, and put them together as an experiment and then do it. It will take about a week or two if you know your things around. But definitely, and I don't expect everyone to have Kubernetes only environment. Most of the large environments are going to be hybrid in nature, meaning Kubernetes, non-Kubernetes for quite some time. So you need a system where you can manage chaos for your application that is running in Kubernetes as well as on the non-Kubernetes. So that's we are very, very clear on that understanding. So yes, so we'll do
So
that.
Oliver has the same question. So I guess that answered your question, Oliver. So another question is: are you applying experiments on Litmus Chaos itself?
Yes, we have. Great question. We have a big E2E pipeline running for Litmus. So we try to break Litmus code itself, right? And we don't want to be getting false alarms. Of course, uh, our other maintainers will say that Litmus chaos experiments, some of them we need to push them to GA, which really means that an experiment has to be run at least 50,000 times by the community. Right? Till then, it's not even if you say an experiment passed or failed, I don't believe, because community has not tested. We are doing it, and some of them like pod kill and container kill, pod delete, hog, all those things are very, very stable. And we did get a lot of issues reported, including the fixes from the community. So the newer experiments we need to see. It goes through a versioning process. We will have some of them moving to GA, some of them moving to GA much later. All that stuff, like any other stuff.
So another one we have is: are there any standard exercises for security perspective for enterprise hybrid cloud environment?
Right. So security is definitely very important, especially in the enterprise environment, if not in the developer environment. You need to be careful. That's where, I mean, right now you can script things around, and you just need to know how to set up all this service account or back policies, and the pod security policies, all that stuff. But we will be trying to do some natural integration with OPA and PSPs for Litmus experiments. And non-Kubernetes security is a beast because there is no common stuff there. So it goes one by one, and it will take time. And that's where I said we have not crossed the chasm. It will take a year or so to get a more common understanding of this. And we want to go to the community to build more minds around it, and then things will happen, right? So
Yeah,
security, you can do whatever you want right now. The architecture allows. You don't have predefined templates for security right now.
I see. So another question from Dudu is, can we integrate other chaos toolings with Litmus?
Yes. In the early days, Litmus did integrate with other chaos tools. For example, Pumbaa was our first underlying tool for network chaos. We used to use some pod delete experiments using Chaos Toolkit, and Bloomberg's powerful seal is already integrated. So LitmusChaos is like a lot of things are there in the infrastructure. The tool set, observability, orchestration layer, and the CRDs and the actual experiments, right? So you can put anything into a Docker container, container runtime, and then run it through Litmus. It's pretty easy, and we call it as BYOC, bring your own chaos, right? So you can just bring in and then push it as a container, and then you can use rest of Litmus capabilities right there.
Okay. So another question is from Rahul, and he is actually asking, how do you perceive CI/CD with? Can you explain with an example? How do you perceive CI/CD?
Right. CI and CD are two different things as far as the chaos is concerned. CI, you need to integrate into the existing pipelines as a chaos stage where you introduce chaos experiments. For example, you're running GitLab. A GitLab CI pipeline, you can introduce a new stage called chaos stage. And then we have a CI library, Litmus CI library, that which is integrated into GitLab remote templates. So if you want to kill an pod on an application in GitLab CI pipeline, you just need to pick up a remote template corresponding to pod kill or a pod delete, and then call them as a remote template call, right? So it is at the outset, it looks like you're just calling on one more GitLab script, but eventually you are calling a chaos experiment, right? Underneath, everything gets done automatically using this library. We will go ahead and install Litmus on the fly, run it, and give the results as a CRD, and you can configure all that stuff as well, right? That is CI. CD is mostly, CD is triggered by a successful CI pipeline, right? And the integration, for example, with Kepten that we did recently, or Spinnaker, is to tell when we can trigger a chaos experiment, right? So that's what CD is. And then you can measure the success of the pipeline or test that run just before, as part of the CD process, right? So you're ready to deploy and you want to again test it in the deployment that you just did. And if things are okay, then continue. Otherwise, you revert it back, right? So that's the CD integration. So we have both CI integration as like CI libraries. CD integration is to tie in with triggering chaos and working with the observability of that system, whatever is being used. It's a great question.
Yeah. So I hope, Rahul, that answers your question. So the another one is from, okay, so I skipped by mistake. So one more question was from Dudu. Are you planning introducing any security features?
Yes. Security for first code level SNCC, we are almost introducing, and security features, there are multiple levels, types of security thing. First is being able to integrate with PSPs and OPA is an immediate roadmap item. And then later on, we need to actually see vulnerability scanning is one type. And can we actually introduce some of the security chaos itself, right? So there are some other projects that are being tried out, setting some good practices around. All those good practices will squeak in, right, into Litmus as well. We're going step by step, right? Have a great architecture, stable architecture, scale it, and security itself is about writing new experiments, right? So it will come, and you can do it. We have done some professional services for some large customers. Those all need to be coming in back into the project, right? So that's the idea of putting more resources.
Yeah, so we'll take two more questions because we are already on time bound. So if you have any further questions, you can definitely join our Slack channel as well. You can ping there, and we can actually go backstage. And then, if you are willing to speak with Uma, we can definitely invite you there as well. So another question from Royce is: it's difficult to run chaos experiments without generating load to the system. Any chance Litmus will expand to being able to generate load as a part of experiment, or somehow making system work together nicely?
Yes, great question, Bryce. This is a very interesting one. I mean, recently we worked with Captain a team. They had a JMeter as a way to load test, right? And they wanted a chaos after, while injecting JMeter stress, you want to do some pod kills and other stuff, right? So we also have FIO stress test, debench stress test as primitive experiments, and we can add them as one of the stages in the chaos workflow, right? So the beauty of the chaos workflow is you can run things in parallel or in sequence. You can just pick a chaos experiment or a stage called generate load. You keep generating that in parallel. You go ahead and run some chaos. So it's definitely possible with Litmus 2.0. With all this portal, we are trying to make it pretty easy to set up as well. Right now, the answer is yes. You can find your way around through the docs, and if you wait for a few more months, it will be right there, very clear.
Thank you, Uma. So, last question for the session. So, can you talk more from the perspective of persistent storage?
Yes, we are the persistent storage guys, right? OpenEBS, that's where we came from. Storage is difficult, right? So there are a lot of failures that can happen in terms of a storage system, right? It's like disk becoming full, disk getting lost, and network to the disk getting lost. These are some type of chaos that you can think of. There are other deeper chaos like IO chaos, right? So what happens if a file system misbehaves? Can you mimic a file system error, right? And can you introduce some overload at IO level, right? So these are next level of stress testing, and IO chaos is definitely under development right now. We are trying to introduce some file system errors. And there is another set of persistent storage errors that can happen depending on application. For example, you take Vitess, right? Vitess is a database that is that can also get into some errors. Can we mimic that errors? Can you take OpenEBS? OpenEBS can go wrong in its control plane or data plane, right? So can we go and introduce? So these are called application-specific chaos experiments. We definitely have such things for OpenEBS. OpenEBS community is using it. And we actually look forward for others to come and use Litmus infrastructure and write them. And we will be definitely working with all these database projects, vendors, as well as storage networking guys to encourage them to write more experiments, right? So stateful thing is the most difficult thing in cloud native ecosystem, right? So that's where we started OpenEBS with, right? So yeah, so things are going to come, but basic things, disk loss and such things are already there. And if you are talking about OpenEBS, deeper experiments are also available.
Sure. So thanks everyone for tuning in. Stay up for the other sessions as well. And thank you so much, Uma, for a great keynote. If you have any other question for Uma, you can definitely join the launch session. He'll be available there. So thanks everyone. Please enjoy the conference.
Yeah. Cheers. A great conference, folks.
Yeah.